All right, this is going over the review quiz, the second review quiz from chapter 16 and 19. Start with number 1. It's a probability question. 2 dice are rolled. Given that the 2 dice are the same number, find the probability that the sum is 6. So I'm finding the probability that the sum is 6 given that they're the same number. Okay? So the sample size is not all 36 possibilities, but it's just all the possibilities where we could get the same number. So it's either a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, or a 5 and a 5, or a 6 and a 6. There's 6 ways that this could occur, that we could get the same number. How many of those ways do we have a sum of 6? Well, only one. So the answer here is 1/36. Several people put, and I just screwed that up. The answer here is 1/6, because there's 6 ways that we could get the same number, and one of those includes having a sum of 6. A lot of people mess that up, or some groups mess that up and put 1/36, but this condition makes it out of 6 and not 36. All right, number 2. You can't plug in cosine, or you can't plug in pi over 2 here because the cosine of pi over 2 is 0, so we have to do something else. And so if we remember the sine of 2x identity, we can apply that. Sine of 2x is 2 sine x cosine x. We can then divide through by cosine of x, and then we can plug in sine of x is sine of pi over 2 is 1, so we get 2 is the answer. All right, number 3. Box A contains 3 red marbles and 2 blue marbles. Box B contains 6 red and 3 blue. 1 marble is selected from B and placed into A. Then a marble is chosen from A. Find the probability that this marble is red. So this is a type of problem that we need to be able to organize what can occur. And so a tree diagram can be helpful here. And a tree diagram would say, okay, we're going to start with box B. This is box B. And we can either get a red marble or a blue marble. And there's 6 out of 9 red in box B. So I'm going to write that the probability of getting a red is 6/9. The probability of getting a blue then is 3/9. And that's 2/3 and 1/3, but I'm going to leave it like that. Okay, then we go to box A. So this branch here represents box A. Now, if originally there are 5 marbles total in box A, but we're putting one in that can either be red or blue, and we're going to draw one out that can be either red or blue. So let me just finish this. Okay, so if the first marble that we take out of B and put into A is red, there are 6 total marbles now in box A, and 4 are red because we just added one. So that's 4/6. That means that 2 are blue. Okay? All right, then, if the marble we take out of box B is blue, okay, and we put it in box A, we now have 6, and we still have 3 red, but now we have 3 blue. Okay? Now, we're finding the probability that the marble that we take out of box A is red. So I have to look at the ways that that could occur. That means I either got a red and a red, or I got a blue and a red. Okay, and we could have probably jumped straight to that without using this whole tree diagram, but I just wanted to show the tree diagram. And so, what's the probability of that? Well, we multiply. It would be 2/3 times 2/3 plus 1/3 times 1/2. Excuse me. Okay, and so if you do that, you get 4/9 plus 1/6. Okay, and this is like 8/18 plus 3/18. That is 11/18. That's how we get our total answer. All right, number 4. Bag contains 6 marbles that are red and 10 that are blue. 4 marbles are chosen. Find the probability that at least one is red. So this is 1 minus the probability that none are red. Okay? When you see finding the probability of at least one, often it's easier to find the complement of at least 1. And at least 1 in this case would be 1, 2, 3, or 4. But there's also the possibility that we get 0 red marbles. And so that's the complement, so I can do 1 minus the probability that none are red. Well, the probability that none are red, there's different ways to do this, but I'm going to do it like this. Well, there's 16 total marbles, and we're drawing 4, so this is 16 choose 4 in the denominator. None are red, so there are 6 red, we're choosing 0 of them, and that means the other 10 have to be something else, so I get that. And if you simplify that, you get 23/26 if you simplify that fraction, once you found it. All right, number 5, an urn contains 5 red marbles and 7 blue marbles. 4 marbles are chosen. Let x be the number of red marbles chosen among the 4. Find the expected value of x. So we could make a probability distribution chart and find it in that way. But if we think about this, there are 5/12 of the marbles in the urn are red. We're choosing 4, so I would expect 5/12 of the 4 to be red. So I can find it in this fashion. This is 20/12, which simplifies to 5/3. Okay? When we get to number 7, I'll show you a different way to do it, but you'll get the same answer. All right, number 6, we skipped. We're not doing number 6. Number 7. Same situation as number 5, except now it's asking you to find a probability distribution for x. And so that's a chart of all the possible outcomes, and we're looking at the number of reds, and so I could get 0 red, 1 red, 2 red, or 3 red, and for the probability of each. Okay, so this is a combinatorics problem. It's not a binomial problem because we're not replacing the marble. The denominator for each one of these will be 12 choose 3. The numerator in this case, and I'll just fill out one of them, is, well, there's 5. This is probably of getting 0 red. That would be 5 choose 0 and 7 choose 3. 0 red and 3 that are not red, that are blue, I guess. This is 5 choose 1 and 7 choose 2. This is 5 choose 2, 7 choose 1, and this is 5 choose 3 and 7 choose 0. Okay, don't leave the answer like this, please. Actually find these values. Okay, this probably would be on the calculator section. This is 35 out of 220. This is 105 out of 220. This is 70 out of 220. And this is 10 out of 220. These all simplify. I think this is 7 out of 44. This is 7 out of 22. This is 1 out of 22. And so these are the final probabilities, okay? I know it's really tempting to just leave it like that, and that's going to be most of the credit, but I want to make sure that you can find these things. So please simplify the fractions and give me this. Now, couple things to notice. 1, if I add these up, they all add up to 1. That means I know it's a valid probability distribution. The other thing is, if I want to find the expected value, I could do it in this fashion. I could do it by taking 0 times 7/44, plus 1 times 21/44, plus 2 times 7/22, plus 3 times 1/22. I could do it in that fashion, and I'll get the same answer that I got for number 5, which is 5/3. Okay? So the way we generally find expected values is to take each value times its probability, and then add up those products. So it'd be 0 plus 7/44 plus 1 times 21/44, and so forth. Okay? Just want to make you aware of that. All right, finally, rational function. We want to factor. Okay, x squared minus 5 does not factor over the integers. However, it does factor over real numbers. Okay, so I'm factoring like that, and then finally, okay, here's it fully factored. Now, I can see that there's no holes, All right, I can see that I have vertical asymptotes at x equals root 5 and negative root 5. Okay, and so root 5 is between 2 and 3, a little bit closer to 2. So I've got this asymptote, and I've got this asymptote. Okay, the vertical asymptote, the limit of this thing as y approaches, or as x approaches infinity, is 2. So that's a vertical asymptote. Okay, the zeros are at 1 and negative 1. So here and here. The y-intercept is at 2/5. Okay, so that's right here. All right. And that's it. Now, does it cross the horizontal asymptote? We should check that. Okay, we can check that fairly quickly. Basically, if we set this thing equal to 2, and we try to solve it, I see that I get negative 2 equals negative 10, so no. No solution. That means this does not cross the asymptote, the horizontal asymptote. And so, in terms of sign analysis, in this part of the graph, there's only one place it can be. It has to be up here, because if it's down here, it's going to cross that x-axis, and we already found the zeros. So it's got to go something like that. Same thing on the left side. It has to go something like that. And then in the middle here, well, I know it connects like that, and then it can't go back up because it would cross the asymptote. We already figured out it couldn't do that. So it's got to go like this. All right, so there's your graph. And that about does it.